Hello everyone, this is a problem video for section 6.1. So I'll just go through several problems of the book and try and see if there's any hard problems on the homework as well. So diving right in, let's sketch the region enclosed by the given curves and find the area. Okay, so problem, let's start with 13 in the book. Let's say we start with y equals 12 minus x squared and y equals x squared minus 6. Okay, so again, the instructions are to sketch the region and find the area. Okay, so sketching the region is a good thing to do even if it's not required, just to get a picture of what's going on with the curves with the region. Okay, so 12 minus x squared. Okay, we don't need to make this too exact. Okay, I know 12 minus x squared is a upside down parabola, and let's see, it should just, it's like, let's see, we could think of this as the parabola negative x squared, and then it's just been shifted up by 12. Okay, these two are the same things. So that's how I think about this curve. Okay, so I'll just do a quick sketch of that. Okay, that's good enough for me. And then what about y equals x squared minus 6? Well, that's an upward facing parabola that's been shifted down by 6. Okay, so it's going to look something like this. Okay, now this is a really quick sketch. So these points where my curves intersect, that might be totally wrong. Let's see. So these blue points here, okay, in my graph, they're up here above the x-axis, but in actuality, maybe a more accurate graph, would look something like, maybe it would look something like this, where those points of intersection are below the x-axis. At this point, I don't really know. One thing I'll say is that they should probably be on the same level. Okay, so we're usually not going to have, one point down here and the other one up here. Okay, that's just a problem with my sketch. So this is just a quick sketch, obviously, maybe not too accurate, but it should be good enough. Okay, it's just to get an idea of what's going on. I know my general region is going to look something like that, and I'm going to have these 2 points of intersection, and I need to figure out where those are. Okay, so let's figure out where these points intersect. Well, those points are going to intersect where the two curves are equal to each other. Okay, so let's set the two curves equal to each other. And then, like I said in the lecture video, if you watch that, let's move everything to one side of the equal sign. Okay, so I get 0 equals 2x squared plus 6, and then, actually, you know what? That's a mistake. That should be minus 18, right? I think I might have done this problem in the lecture video, but doesn't hurt to do again. So if I just divide out that 2, I can divide both sides by 2. Okay, and I get 0 equals x squared minus 9. And then I factor this. Factor or doing the quadratic formula would give us the same results, that this thing has solutions where x equals positive 3, x equals negative 3, which means these curves are going to intersect where x equals positive 3 and x equals negative 3. And now, if I plug these into one of my equations, I'll figure out the y coordinates, and so I'll have a better picture of where these points are. So if I plug 3 into the equation 12 minus x squared, okay, plug in 3 for x, and I get 0 equals 12 minus 9, or excuse me, y equals 12 minus 9. So y equals 3. Okay, and if I plugged in negative 3, I would get the same thing. So I know my curves intersect at negative 3, 3, and positive 3, 3. Okay. So my curves actually look like I get a better picture of my curves now. They intersect up here at these points, 3, 3, and negative 3, 3. Okay. All right. So I've just improved my picture a little bit here. But to find the area, what do I need to do? I need to do one curve minus the other. So top curve minus bottom curve, right? The top curve is this one, which is the 12 minus x squared. And then I need to subtract the bottom one, which is x squared minus 6. And I need to integrate where? From where they first meet, and x equals negative 3, to where they meet at x equals positive 3. So I need to integrate from negative 3, 3. All right, so let's just simplify our integral a bit. So we get this. Integrating this. I get this antiderivative evaluated at these bounds. Okay. So plug in those numbers in. Let's see. I get 54 minus 2/3 times 27 minus negative 54 minus 2/3 negative 27. Okay, kind of ugly. So let's simplify. Let's see. Should be 72, it looks like. And double check me on all that. Okay. So in this problem, I kind of talked through it a lot and gave you a lot of my intuition. Now I'll kind of solve this problem how I'd like to see it solved on tests and so forth, and kind of do as little work as possible. That's how I'll do the future problem. Okay, this problem I won't explain as much. I'll try and explain as I go, but I'll try and keep the writing as neat as possible and keep it more representative of what I would like to see from you guys. Let's try number 18. We have y equals square root of x minus 1, and then x minus y equals 1. Same instructions, sketch the curve and then find the area enclosed. Okay, sketch the curves. Okay, so let's see. Sorry about that. So first thing I do is I sketch the curves. Well, let's see, square root of x would look like this. And then square root of x minus 1, that's just the square root curve, but shifted to the right by 1. Okay, so my curve should look like this. All right, and what's x minus y equals 1? Well, that's the same as, let's see, negative y equals negative x plus 1 equals y equals x minus 1. All right, so that's just the line with slope 1 starting here. Okay. So it looks something like that. So the region I'm looking for is this stuff in here. Okay. All right. Now what do I need to do? I need to find these points where these curves intersect, right? Okay. This one looks like it's at the point 1, 0, but let's make sure. Okay, so how do I find the points where they intersect? I set the two curves equal to each other. So x minus 1 equals what? X minus 1. Square root of x minus 1 equals x minus 1. Okay. So how do I find that? Well, this square root thing's throwing me off, right? But let's square both sides and see what happens. Okay, if I square the left side, I just get x minus 1. If I square the right side, okay. And then again, let's move everything to one side of the equal sign. I get this thing. And then factoring, I could factor this as x minus 1 and x minus 2. So this has solutions x equals 1, x equals 2. Okay. So it looks like this curve, these curves intersect at x equals 1, and then this point would be x equals 2. All right. So that means I know I need to integrate from 1 to 2. And what am I integrating? Top curve minus bottom curve. What's the top curve? It's that square root of x minus 1. Okay. What's the bottom curve? It's that line, y equals x minus 1. And the rest is just integrating. Okay. So let's see, we might require a u substitution on this part, right? How could we solve this integral? Well, we could do it two ways. We could either break it up into two integrals. We could do this integral minus this integral, right? And this will give me a number, this will give me a number, and then I just subtract this number from that number. Okay, so that would give me my answer. Or I could do a u substitution and keep this all together. So let's see, I need to do u substitution. I could do u equals x minus 1, then du equals dx. So this integral would become square root of u minus u du. Integrating that. Okay, I get this. Undoing my substitution. I get this. And then plugging in my bounds, what do I get? So basically it just is 2/3 minus 1/2, which should be 1/6, I believe. Let's see. Yeah, 1/6. So final answer 1/6. So a lot of explanation, but what I've written is kind of the streamlined version and how I'd like you guys to solve them. What I do, I sketch the curves. I quickly found where the curves intersect to find my bounds of integration. I wrote my integral and then just solved my integral. And yeah, the integral required a u substitution, but nothing too major. Okay, let's try one more from the textbook. Let's try number 27. So we have the curves y equals 1 over x, y equals x, y equals 1/4 x, and x greater than 0. Okay. So let's try and graph this region first. Boom. Okay, just graphing the curves individually first. Let's see, 1 over x. What does that look like? It should shoot up here. And then as x gets bigger, it should get really close to 0. Looks something like that. What's y equals x? Well, that's just that diagonal line, right? Y equals 1/4 x. Well, that's another line there. And then x greater than 0. So we need to be to the right of our y-axis. So it looks like that region they're talking about is just here. Okay. Okay, so I need to find my bounds of integration. This is one of these problems where we actually need to split our integral up into two. Okay, so first, let's see, where do I need to, I'm thinking about what's my top curve, what's my bottom curve. Well, in this left piece, this line is my top curve, right? Up until I get to this dotted line, okay? Then this 1 over x is my top curve, right? Okay. So basically I need to integrate this left piece from here to there, okay? And then I need to integrate this right piece with the other curves from here to here, okay? So I need to find the intersection points, these intersection points. So to find how to integrate this left piece, okay, what curves do I need to deal with? I need to deal with this curve. I need to find, let's see, where this curve intersects with this curve. That'll give me this point. And then I need to find where this curve intersects with this curve. That'll give me this point, right? Okay. Well, this point, maybe it's clear that that's the point x equals 0, right? Where does y equals x, where does that equal 1/4 x? Well, where x equals 0. All right. And then what's the other points? We need to find out where x equals 1 over x. So where does x equal 1 over x? Okay. Solving, I get multiplying x to both sides, I get x squared equals 1. X squared minus 1 equals 0. Where does that occur? Well, where is this true? At x equals, we could factor this as x minus 1, x plus 1. So that's going to happen at x equals positive 1, x equals negative 1. Since we have this condition, x is greater than or equal to 0, we can ignore this answer. Okay. So this point where our curves intersect is going to be at x equals 1. So my first region should be 0 to 1. What's my top curve in that region? Y equals x. Okay. What's my bottom curve? 1/4 x. So this should give me the area of my left piece. Okay. Now let's do the right piece. Okay. So I need to find where my curves intersect. Let's see. I know. Let's clean this up a bit. It's getting a little messy. Now I'm looking at this right triangle, this right, or it's not really a triangle, right? I'm looking at this right piece, okay? It starts here, and we just found out, okay, that's the point, that's the line x equals 1. And then where does it end? Okay, so now I need to find that right endpoint, okay? So I'm gonna set two curves equal to each other. Which curves? I need to find this intersection point, which is, let's see, I need to find, okay, where this y equals 1 over x intersects this line, which is y equals 1/4 x. So I'll just do that right here. I'm gonna set 1 over x equal to 1/4 x and solve. Let's see, multiplying this x over to the other side, I get this. Okay, moving everything to one side, I get this. Let's go ahead, you can do quadratic formula on this. The way I would do it is just multiply both sides by 4. The left side won't change, and then the right side will become x squared minus 4. And now this thing's easy to factor. Okay, so we get, it factors as x minus 2 times x plus 2. This has solutions positive 2, negative 2. Again, since we're assuming x is greater than or equal to 0, we ignore that one. Okay, so my left region, or excuse me, my right region should be from 1 to 2. And what's my top curve? What's my bottom curve? Okay, top curve is going to be that 1 over x. Bottom curve is going to be 1/4 x. So this expression should give me my total area. So I just need to solve my two integrals. Let's see. So I should have this. And now I just need to plug in my numbers. Okay, so I should have, let's see, 1/2 minus 1/8 plus, let's see, ln of 2 minus 1/2 minus, let's see, ln of 1 is 0 minus 1/8. Simplifying this, let's see, I have 1/2 minus 1/8 plus ln of 2 minus 1/2 plus 1/8. So let's see, this 1/2 should cancel with that 1/2. This 1/8 should cancel with that 1/8. So I should be left with ln of 2, I believe. And again, I might have made some arithmetic mistakes, so double check me on that. Okay, let's start looking at some problems from the homework. The first couple problems are finding these intersection points of graphs. Okay, so maybe it's a little weird how they present it, but it's the same method we've covered so far in the lecture. So I'll kind of write out so number 1 on the homework, what they give you is they give you this system of equations. And then they ask you to find intersection points. Okay, so how would I do this? First, I'm going to take each of these equations and write them in the form y equals blah, blah, blah. Okay. So the first one would become y equals negative x squared. The second one would become, let's see, y equals x cubed minus 6x. Okay. If we rearrange this bottom one, we should get this. Now what am I going to do? I'm just going to set these equations equal to each other. So I'll set negative x squared equal to x cubed minus 6x. I'm going to move everything to one side of the equal sign. Then I'm going to solve. How do I solve that? Well, let's try factoring. Okay. So I factor out an x, then that quadratic, I can factor further. That would be this. And so this has solutions x equals 0, x equals -3, x equals +2. Okay. So this gives me all the x coordinates. How do I find the points? Well, the points are going to look like this. I'm going to take x equals 0 and plug it into either one of these equations. So if I plug it into this bottom equation, see, I get 0 minus 0, so I get the point 0, 0. Now I'm going to take x equals -3 and plug it into one of these equations. So let's say I plug it into this. Okay, -3 squared is 9. Then I have a negative out front, so -9. Okay, last I'm going to plug this into an equation. So let's say, again, I plug it into this equation. 2 squared is 4. Then I got a negative out front, so I got the point 2, -4. Number 2, same thing, but now instead of points, they just want the x values. Okay. So number 1, they want the points. Number 2, it looks like they just want the x values. Number 3, it looks like they want points again. Number 4, number 5, number 6 are pretty straightforward. Let's talk about number 7. This is a case I forgot to talk about in the lecture video. Okay. Everything I talked about has been when we have these y's as a function of x, like y equals x squared plus 6, and y equals, let's say, this. So the intersection that would look like that. Okay, that region. So when we have, instead of y equals a function of x, if we have x equals a function of y, everything's going to be sideways. Okay, so x equals y squared would look like this sideways parabola, and then x equals y. Well, that would still be this line. Okay, how do I find the area of this thing? In this case, we could do it either way, but there are some cases where instead of doing top curve minus bottom curve, we need to do right curve minus left curve. Okay, and number 7 is one of these cases. So let's say I have x equals y squared minus 8y, and x equals 5y minus y squared. And I'm told to draw this region, and well, in this, I'm just told to find the area. They give me the region, right? The region looks something like this. Okay, so I got these ugly parabolas, and they give me this shaded region. We're told to find that area of that shaded region. Okay, so if we were trying to do the top curve minus bottom curve, that'd be hard because like for this piece, the top part is this curve, and then the bottom part is that same curve. Okay, so it gets a little weird. Okay, so the way we deal with this is instead of doing top curve minus bottom curve, we do right curve minus left curve, okay? And that's usually what we're going to do when we have these x's as a function of y. So how do I set this problem up? Okay, my integral needs to be in terms of y. So I know I'm going to have some, instead of having dx here, I'm going to have dy. And I need to do right curve minus left instead of top minus bottom. Okay, so what is the right curve? Well, the right curve is this thing, which is, let's see, that would be 5y minus y squared. And then the left curve would be this thing, which is y squared minus 8y. And then the next thing I need to do is find my bounds of integration, right? So I need to find these intersection points. So how do I do that? Just like in the previous case, I set the two curves equal to each other. So I'm going to set 5y minus y squared equal to y squared minus 8y. And I'm going to move everything to one side of the equal sign and then solve for y. So let's see, have I done this correctly? So I would add y squared to both sides and subtract y squared from, or excuse me, 5y from both sides. Yeah. And then I need to solve for y. So this doesn't look like I can factor it nicely. So how I would do this is quadratic formula. Let's see, if you can factor this, great. For me, if anything, if it's too ugly, I just go back to quadratic formula. So let's see, negative b plus or minus b squared minus 4ac all over 2a. Okay, so what's my a, b, and c? This is my a, this is my b, and then my c is just 0. Okay. So let's see, negative up negative 13, so I'd have positive 13 plus or minus 69 minus 4, 2 times 0 all over 4. So 13 plus or minus 13 over 4. So it's either 26 over 4 or 0. So 13 over 2 or 0. Okay, so not too bad. And now looking at this, it seems like this is actually really easy to factor, right? Okay, and now that I've actually solved it out, it's actually easy to factor. This would factor as y. We could divide both sides by 2. So yeah, now it's clear that the solutions are y equals 0, y equals 13 over 2. So either way. All right, so that means my bounds of integration should be 0 and 13 over 2, and then I integrate my right minus left. Okay, so that was 5y minus y squared minus y squared minus 8y. Okay, let's go ahead and simplify. Integrating. This is, messy, like a lot of the WebAssign problems. Plugging 13 over 2 in. Let's see. I got a 13 over 2 out front, and then I got 13 over 2 squared which is, let's see, 169 over 4. Okay. Actually, let's see, we can make this a bit easier on ourselves. This is 13 over 2 squared, right? From this y squared. Okay, times 13 over 2. So I have 13 over 2 to the power 3 minus 2/3. 13 over 2 to the power 3. Okay, that's just my first piece. And then I plug in 0 and I get 0. Okay. So I have 1/3 times 13 over 2 to the power 3. So I have 13 cubed over 24. What's 13 cubed? 2197. So that should be my final answer. Okay, looking at the rest of the homework, doesn't seem too bad. I think this will kind of cover the last of the maybe tricky problems. The other ones we've seen some examples of how to solve. So let me know if you have any questions.